From space, Earth looks like a shimmering blue marble, a planet defined not by its land but by its water. The oceans cover over 70% of our surface, holding 97% of all the water on Earth. Yet what's astonishing is not just their size, but their role. The ocean is the silent architect of our planet's climate. It controls temperature, drives weather, and even shapes the air we breathe. Without the ocean's stabilizing hand, our planet would be unrecognizable. A world of brutal extremes where life might never have flourished. Welcome to Mattermosaic, piecing together the universe, one discovery at a time. Today, we're diving deep beneath the surface to uncover how the ocean keeps our climate alive. A global system so vast, so interconnected, that it acts like Earth's beating heart. The mystery. The ocean, Earth's hidden climate engine. When we talk about climate, we often imagine the sky, storms, wind, clouds, and sunlight. But the real power lies below. The ocean stores and redistributes heat, captures carbon, and drives the very cycles that make Earth stable enough for life. It's hard to overstate this influence. The ocean holds about 1,000 times more heat than the atmosphere, acting as a planetary buffer, absorbing excess warmth and releasing it slowly over centuries. If the atmosphere is Earth's breath, the ocean is its bloodstream. It moves energy, nutrients, and gases across the globe in an endless rhythm. This balance is delicate, elegant, and, until recently, nearly perfect. The mechanism. How the ocean moves. Heat around the world. The story begins with sunlight. Near the equator, solar energy warms the upper layers of the ocean. Warm water expands, becoming lighter, and flows toward the poles through powerful surface currents. Most famously, the Gulf Stream in the Atlantic. As this warm water travels north, it releases heat into the air, warming nearby continents. Eventually it cools, becomes denser, and sinks into the depths, creating a slow, deep current that moves southward. This immense loop, known as the thermohaline circulation, is driven by differences in temperature, thermo, and salinity, haline. It's sometimes called the global ocean conveyor belt because it connects every ocean basin in a continuous cycle that can take up to 1,000 years to complete. This circulation doesn't just move water, it moves climate itself. It's what keeps northern Europe far warmer than other regions at similar latitudes. It moderates monsoons, stabilizes storm systems, and prevents runaway temperature extreme. But the system is fragile. A shift in temperature or in the amount of fresh water from melting ice can alter the density of seawater and weaken the entire flow. Scientists worry that parts of this conveyor may already be slowing down. If it collapses, the results would be catastrophic, plunging regions into deep cold, shifting rainfall patterns, and disrupting agriculture and weather across the globe. The carbon connection. How the ocean breathes for the planet. The ocean is not only a heat regulator but also a carbon regulator. It acts as the planet's largest carbon sink, pulling vast amounts of carbon dioxide from the air. This happens through two intertwined systems, the physical pump and the biological pump. In the physical pump, carbon dioxide dissolves in surface waters. When these waters cool and sink in polar regions, they carry that carbon down with them, effectively storing it for centuries. The biological pump, on the other hand, involves life. Trillions of microscopic organisms called phytoplankton float near the surface, using sunlight and CO2 to produce energy. Just like plants on land, these tiny organisms generate about half of Earth's oxygen, and when they die, some of the carbon they've absorbed sinks into the deep ocean, locking it away in sediments for millennia. This constant exchange keeps atmospheric carbon in check. Without it, Earth's climate would have spiraled out of control long ago. But this balance, too, is being tested. A system under strain, warming, acidification, and uncertainty. Since the Industrial Revolution, the ocean has absorbed more than 90% of the excess heat trapped by greenhouse gases. While this has slowed the pace of surface warming, it has come with enormous consequences below. Warmer waters are expanding, raising sea levels and intensifying storms. Marine heat waves, once rare, now happen regularly, devastating coral reefs that shelter a quarter of all marine life. Meanwhile, as the ocean takes in more carbon dioxide, its chemistry changes. CO2 reacts with seawater to form carbonic acid, lowering the ocean's pH in a process known as ocean acidification. This makes it harder for shellfish, corals, and certain plankton to form calcium carbonate shells, weakening the base of the marine food web. If the smallest organisms falter, the ripple spreads upward, through fish, through ecosystems, and ultimately, to us. The water-climate feedback loop. The ocean and the atmosphere are locked in a continuous feedback loop. Warmer air heats the surface, causing more evaporation. This adds moisture to the atmosphere, fueling storms and altering rainfall. In turn, changing wind patterns affect ocean currents, shifting heat distribution and further changing weather. This cycle is not stable, it's dynamic. A small imbalance can cascade through the system, amplifying change. That's why scientists monitor ocean temperature, salinity, and current so closely. They are not just indicators of climate change. They are the mechanisms driving it. The meaning, the ocean as the memory of Earth. Every wave carries a trace of the past. The deep ocean still holds the chemical fingerprints of ancient climates, hints of ice ages and warm periods long gone. When scientists sample ocean sediments, they read the planet's diary. Layers of dust, isotopes, and microfossils that tell stories of balance and disruption. It's through this record that we know how vital the ocean's role truly is. During Earth's warmest periods, circulation patterns shifted, and the climate grew unstable. When those flows restored balance, life rebounded. The ocean remembers everything. It is both the witness and the regulator of our planet's evolution, a system vast enough to cradle life, yet sensitive enough to respond to even the smallest human touch. Looking ahead, can the ocean save us again? The ocean has protected life for billions of years, but it cannot keep absorbing our excess forever. Scientists estimate that the capacity of ocean carbon uptake may plateau this century, as warmer water holds less gas and circulation slows. Yet, hope lies in understanding. By studying ocean-atmosphere interactions, researchers are improving climate models, restoring marine ecosystems, and developing technologies that work with nature, like kelp forests and artificial upwelling, to enhance carbon storage. More than ever, we are learning that protecting the ocean isn't just an environmental goal. It's an act of self-preservation, because the same system that moderates our seasons, feeds our air, and shields our coasts, also sustains every breath we take. The ocean doesn't speak, but it tells a story, one of rhythm, balance, and endurance. It reminds us that stability is never permanent. It must be maintained through harmony and respect for the interconnected web of life. Every gust of wind, every drop of rain, and every heartbeat on land begins, in some way, with the sea. This is Mattermosaic, piecing together the universe, one discovery at a time. If this video inspired you, leave a like, share it with someone who loves science, and tell us what part of the ocean fascinates you most. Subscribe for more weekly journeys through the fabric of reality.